Well, good morning, everybody. So today the notes that I'm going to be working with are from page 88 and 89 and go along with assignment on page 91. We're going to be talking about compound inequalities today. So we've worked with inequalities where we do an open or a closed circle and the arrow goes either to the left or to the right. Now a compound inequality is going to be a combination of two inequalities, and they will both be graphed on the number line at the same time. So there are two versions of them. There are and or compound inequalities. When you graph the two inequalities on the same number line, an and compound inequality tends to graph together. So you will see an arrow from the right going to the left, an arrow from the left going to the right, and then those two arrows run into each other, and it becomes one line. Or compound inequalities tend to graph apart. So you will graph both inequalities, but you will find that they go away from each other. The one thing that they'll never do is both go in the same direction. If you find that your inequalities have gone in the same direction, one arrow to the right and the other arrow to the right, or one arrow to the left and the other arrow to the left, then you've definitely made a mistake and you're going to want to go back and check and see where that might have happened. Let's take a look at an example of what we're going to be doing in this lesson and what an and an or compound inequality looks like. So first of all, as an example, we have two inequalities here. This is an or example. So my arrows should go apart when I graph them. I'm just simply going to graph them each at the same time. So here we go. X is less than or equal to negative 2. Less than or equal to means above negative 2. I'm going to have a solid circle. Less than or equal to negative 2 would be an arrow to the left. I'll wait to see here before I draw my arrows, though. The other one is X is greater than 3. So I'll use an open circle above 3. Greater than 3 would go to the right. And so this or inequality graphs with my arrows going apart as we predicted. Now in this lesson, we also take the time to write our answers in interval notation, something I want to show you how we do that. So interval notation, I've shown you the brackets and the parentheses before. In an or compound inequality, you're going to have to write two intervals. So the first one will be here to the far left where the arrow heads towards negative infinity. Since negative 2, since our inequality can be equal to negative 2, that's where we'll use a bracket. Around the 3, we'll have a parenthesis and a second parenthesis as this heads to positive infinity. All we have to do is write the interval notation just like that. So we're going to have parenthesis, negative infinity up to negative 2, and then parenthesis 3 to positive infinity. One other thing I would like to show you, though, is how you could write this or inequality as a single inequality. So if I write the negative 2, which is further to the left on the number line here, and positive 3, I'm going to write it with a single x. Now this one here is going to stay the same. X is greater than 3. And then this one will have to pancake flip-flop. Since the x is now written on the right, we want the pointy side of our inequality to remain pointing towards the x, so less than or equal to. On occasion, you'll see them written like that, and you'll need to be able to separate them and recognize them as two separate inequalities. Though this is a little bit more challenging because you don't recognize that it says or yet. You can only put that in later on. Let's go ahead and do another example just like that. This time it's going to be an and example. My first is x is greater than or equal to negative 6, so above negative 6, I'm going to do a solid circle. Greater than or equal to negative 6 says my arrow will go to the right. Let's see what happens here before we draw it. My second one says x is less than or equal to 1, so it's a solid circle above 1. Less than or equal to 1 would be an arrow to the left. So I have an arrow to the right, an arrow to the left. All I'm going to do is connect those, and that is the graph of this and compound inequality. Let's go ahead and write its interval notation. There will only be one interval. In this case, x can be equal to negative 6 and x can be equal to 1. And those are going to be the two values that I include in my interval, negative 6 to 1 and brackets on both sides. If this AND inequality was written as a single compound inequality, here's how it would look. We're going to write negative 6 is further to the left on the number line and 1, x in between them. This particular inequality is going to stay the same, less than or equal to. And then this one would again need to be pancake flip-flop. This time the alligator mouth stays open towards the x. So I'm going to go ahead and make sure that that happens here. Stays open towards the x, and there it is written as a single compound inequality. Our job today is we're going to be solving OR and AND inequalities. So we will solve two inequalities separately. We'll graph the line, and then we'll write them in interval notation. We're going to do that on each one of these. So here we go. This OR inequalities do tend to be a little easier since they usually start out separated already for us. So let's take a look. X minus 4 less than negative 7. I want to isolate x by adding 4 on each side, canceling out the 4's, gives me x is less than negative 7 plus 4 is going to be a negative 3. I'm going to solve the second one before I try graphing anything. In this case, 2 times x is greater than or equal to 12. All I have to do is divide both sides by 2. Cancel out the 2's on the left side, gives me x is greater than or equal to 6. Now it's an OR inequality, so my prediction is that the arrows will go apart when I graph them. Let's take a look at how that turns out. I'll draw my number line. On your note-taking guides, the number lines are already drawn for you. Just fill in the numbers. So I'm going to have negative 3, 2, 1, 0. I do have a habit of drawing in 0 because it just makes things more clear. 1, 2, 3, 4, 5, and 6. Above negative 3, I have an open circle, and it looks to me x is less than negative 3. The arrow will go to the left. Above 6, we have x is greater than or equal to 6. That's going to be a solid circle. Greater than or equal to 6 goes to the right. So here we go. Now I'm going to draw my interval. This one heads towards negative infinity and a parenthesis around an open circle. We have a bracket to positive infinity. Infinity always has a parenthesis, and let's write that out. Our interval notation was negative infinity to negative 3 with a parenthesis, a bracket around 6, and that one heads towards positive infinity. So there's my interval notation, my graph, and my solved inequalities. We have another OR inequality to solve here for number 5. This one looks like I'm going to solve them separately. So in this case, I'm going to start with distribution. I'm going to distribute my negative 3, gives me a negative 6x minus 3 less than negative 15. Let's go ahead and isolate x all the way, and then we'll solve the other one. Looks like I first need to add 3 to both sides. That's going to be negative 6x is less than negative 15 plus 3 is going to come out to a negative 12. And my final step, now this is important, I'm going to have to divide by negative 6. Let's not forget the rule that if you multiply or divide as one of your steps of solving an inequality by a negative number, you have to flip the inequality. If you forget to do that, your arrows will end up going in the same direction. So the moment that I divide by negative 6, I'm going to flip my inequality and make this a greater than symbol. I have x is greater than or equal to negative 12 divided by negative 6 is going to be a positive 2. So we've solved our first inequality. Hopefully I have enough space to graph this for you guys. Let's go ahead and get this one solved. So the next thing I'm going to do here, it looks like first I need to cancel out this positive 1 by subtracting 1. I'm going to get a negative x is greater than or equal to a positive 4. 5 minus 1 is 4. And just like the previous example, I'm going to have to divide by negative 1. If I multiply or divide by a negative number to solve for my variable, I have to flip my inequality. The moment I divide by negative 1, I flip my inequality. It becomes less than or equal to, so x is less than or equal to 4 divided by negative 1 is negative 4. I have just enough space to do it, so here we go. Let's graph this. This is an OR inequality, so my arrows should go apart when I graph it. I'm going to need to include negative 4, 3, 2, 1, 0, 1, 2 on there. And let's see, x is greater than 2. So that's an open circle above 2, arrow to the right. X is less than or equal to -4. That's a solid circle above -4 with an arrow to the left. Now, let's write our interval out. This one's headed towards -infinity with a bracket around my solid circle. I have a parenthesis around 2 because of the open circle, and a parenthesis as it heads towards positive infinity for the interval -infinity to -4 with a bracket. Parenthesis 2 towards positive infinity. So there's my interval, my graph, and my 2 solved inequalities. Let's turn the page, and I believe that we're going to start taking a look at and inequalities. So I've got just a couple examples of these. Remember, the and inequalities should be ones that end up graphing with the arrows facing towards each other. So it says, because the solutions to an and inequality fall between two endpoints, they're frequently written in a more condensed form. So it's and inequalities that tend to be written as one large inequality, as you see here. Here they are separate. X is greater than -1 and x is less than 5. This can be rewritten with a single x. Just put the numbers in order as they would fall on a number line. -1 is further to the left than 5 on a number line. Put the x in between. One of your two inequalities will look the same as it does. X is less than 5. The other one will have to be pancake flip-flop. Just make sure that either the alligator mouth or the arrow remains pointing towards the x as it is in the original. So opened alligator mouth faces the x in this case as well. Now, because they're written in this more condensed form, we're going to have to separate the two inequalities prior to solving them, or at least that's how I like to do it. So I go from the far left, past the inequality symbol, up to the other one. That's going to be my first equation. So I'm going to write that. I have 2 is less than or equal to x plus 4. And my second one starts after the first inequality and goes to the end of the other. So this will be x plus 4 is less than 9. So this is really, really consistent. This is an and inequality. Let's separate, let's solve them both, and we'll go through this process again. To get x by itself, I'm going to start by subtracting by 4. That cancels out my 4's. -4 plus 2 is going to be a -2 is less than or equal to x. Now, I would like to be able to read this left to right with the x written on the left. Open mouth towards the x, I'm going to keep it greater than, it's going to be greater than or equal to -2. Let's go ahead and isolate and solve for x in our second one. X plus 4, so I'm going to start by subtracting 4. That's going to give me x is less than 9 minus 4 is 5. Let's go ahead and graph these on the number line. They should face each other when I've done that. Here we go. We draw our number line. On my number line, I'm going to need -2 all the way to 5. So let's start with -2, -1, 0, 1, 2, 3, 4, 5. Above -2, I will have a closed circle greater than or equal to. Above my 5, I will have a open circle less than 5. Now, greater than or equal to -2 would be to the right. Less than 5 will be to the left, so my arrows will connect. And my interval, I'll have a single interval, should be pretty easy to write. I have a bracket around -2 and a parenthesis around 5 for the closed circle and the open circle. So my interval will be -2 to 5. I'm going to do just one more of these with you. I chose number 9 because it includes that fraction. Let's go ahead and start by writing our inequalities separate from each other. So all the way to the left up to the second inequality symbol. So that's a -1 less than 2/3 x plus 1. And start after the first inequality symbol all the way to the end of the second. We have 2/3 x plus 1 less than or equal to 5. So for this one, let's go ahead and let's rewrite this. I don't like to have the fraction out front, you guys know that, so let's go ahead and write this as a 2x over 3. So we have a negative 1 less than 2x over 3 plus 1. And we have a 2x over 3 plus 1 less than or equal to 5. Now that's just a personal preference. Some of you may have been taught to multiply by the reciprocal, which is fine, but I find that this is a little bit more clear for students new to this subject. Let's go ahead and isolate x. It's going to take us 3 steps. I'm going to subtract by 1, multiply by 3, divide by 2. So we subtract by 1. Now, a 1 minus 1, that's a 0, and a negative 1 minus 1, that's going to give me a negative 2 less than 2x over 3. The next step will be to multiply both sides by 3. Canceling out the 3's gives me a negative 6 less than 2x. And finally, we're going to divide by 2, and that is going to give me a negative 3 less than x. I'm going to rewrite that so I can read it left to right. X is open mouth towards the x, greater than negative 3. Ready to graph. Let's solve the second side. Here we go. So first, I'm going to go ahead and subtract 1 from both sides, canceling out the 1's. That leaves me a 2x divided by 3 less than or equal to 5 minus 1 is 4. Multiply both sides by 3, canceling out the 3's. Gives me 2x is less than or equal to 12. We finish by dividing both sides by 2, and we get x is less than or equal to 6. Now this is an AND inequality, so my arrows should go together when I graph it. Let's draw our number line with the numbers negative 3 to 6. So here we go. Start with negative 3, negative 2, negative 1, 0. 1, 2, 3, 4, 5, 6. Above my negative 3, I'm going to have an open circle for greater than. I'm going to have a closed circle above 6 for less than or equal to. Greater than negative 3 means my arrow goes to the right. Less than or equal to 6 means arrow goes to the left, which means that they will connect in a single interval. Let's write our interval notation, parenthesis around negative 3 and bracket around positive 6. So my interval will be negative 3 to 6. I know a lot of students like to write their final answer in that fashion. We've got our solutions, our graph, and our interval notation. I look forward to working with you guys on Google Classroom.